Okay, so let's talk about graphing polar equations for a sec. So first things first, let's graph easy polar equations. How can I graph the equation r is 2?
Chart of origin.
No.
Circle.
Good. So this is all the points, right, where the radius is 2. So that looks like a circle. And what's the radius of that circle, you ask?
2.
No, you don't, because you guys are smart. Okay, cool. What's the theta allowed to be in here?
Anything.
Anything. Why is the theta allowed to be anything?
Because it's just moving around the circle.
Because it's not specified in the equation, right? So it can be whatever the heck it wants to be. So you set the radius as 2 and then sweep through all the angles theta. Okay, so if I thought about this thing as a function, right, I would be thinking this is r of theta is 2, right? And so the domain of this function is all real numbers, right? You guys see that? And the range is, notice that I'm not squishing these in the usual directions. You guys see that?
Yeah.
Because this thing takes thetas, thetas being angles,
The range
and so I'm
is
wondering the angles that work,
2
fine,
only.
and the range is only the number 2. You guys see that?
Yeah.
So this is radius as a function of angle, right?
It's a horizontal line.
Yeah, and so this is a lot like a horizontal line. You guys see that? So some places you'll get these Cartesian graph papers for polar coordinates. I'll show you this trick when we get a little further. So this is in the xy plane, right, that I'm getting this circle. In the r theta plane, oops, theta should be our input variable, r should be our response. What does this thing look like? Yeah, here this is just a horizontal line, right, where r is 2. 1, 2. You guys all see that? So somehow this thing in the theta r place makes this thing in the xy place. You guys with me on that? Okay, should we try a slightly harder one?
Sure. Is that a vertical line?
Okay. So in the kind of r theta place, so we're going to put theta that way, r this way, because that's what we did last time? Sure. Okay. In that place, this is a what? This is a vertical line, right? At pi over 3. Right? Because the r doesn't matter at all. The theta is just pegged at pi over 3. Okay, what does that look like in the xy plane?
Line.
Good. So this is go to 60 degrees, right? Okay, so I go to pi over 3. Oops, and then I drew that. What's that?
That is infinite radius. Any radius.
Yeah, that's any positive radius, right? You guys see that? Okay, so does this thing specify that the radius has to be positive? No, but it's kind of a convention. I don't really know whether the right answer to this is this line or back down the other way. I'm going to leave it like this. But if you guys completed this line, like you went straight through, I'm okay with that too.
Well, wouldn't it be specified like
Yeah, so let me just kind of
4 pi over 3? Wouldn't it be specified as well?
Yeah, maybe. I'm just going to write this off to the side so we don't have to deal with that ambiguity. You guys cool with that? So I'm gonna add to this an r is bigger than or equal to 0. If that's not added, both answers are sort of right. Cool? Alright, you guys ready for a hard one?
Yes, I thought that was gonna be hard.